Welcome to video lecture 25. In the last video lecture 24, I showed you how to create a parameter constructor. And now we're going to finish building out our simple date class, at least as it relates to initialization. So remember now that we have this initializer, so we get automatic initialization as long as we declare our date variables as we do in 22 through 24. And so now we don't forget to initialize, but there's more that we can do. So right now, our date class is in danger of being corrupted because I can directly access the internal data members. And so that's where bugs can enter in. I can say, hey, month equals 13 and my b-day day equals 32, and now if I print it, now I've got this bogus date here that shouldn't happen. And so what's the point of going object-oriented and using an automatic initialization constructor if I can still corrupt my class? So this is where public-private comes in. So I'm going to move public down, and I'm going to put it right before the date constructor. And so date is public, and display my date is public, but now integers m, d, and y are private. And whenever you're in class, they're private by default. But if you want to be explicit, you can also say private. So now you're beginning to see the concept of an interface. So everything that's public, these two methods are public. That means that a programmer can use those methods because they are public and there's visibility to use them from the program. But the internal data members are private so that we can't just go directly after them and corrupt them. So now this should not compile because line 31, I'm illegally trying to access private members. So let's see what happens. And sure enough, M is a private member and D is a private member. So then you might say, well, then what's the point if you can't change those values? And of course, we want to be able to change those values. And so that's where we will create more methods. And these methods, I call them getters and setters. Other people call them mutators and accessors. And other people call them helpers. But that's okay. So let's say I need a function to be able to set my year. And I'll just say int n because it's going to come in as a number. And I'll simply say y, which is from line 7. That's one of our private data members, and that represents the internal year, the state, and I'll say set it to n. So now I'm able to call this method or send a message to the object, the set year message, and have it update an internal variable, data member y, through the use of a very explicit setter function. And what if I just wanted to display the year? Then I could simply say void get year, no parameters. And I could simply say return y. Now I've created a setter and a getter for the year. And so it's very clear in my code what it is I'm trying to accomplish. So I'll change M to my real birth year. And I won't set it to my real birthday. Okay, so now let's try and compile this. Oh, that's a simple mistake. I said void instead of int. There we go. And so now when I run it, you can see after the call to set year, I've updated the year. And if I wanted to just print or get the year just to display the year alone, I could simply say my bday dot get year. Now, it's not going to display it, but it did return it. And so I might use this in a cout. I was born in the year my bday dot get year, because that returns an integer, followed by a period, a new line. There we go. Now we can take this even further and set year would allow me to pass an invalid date. So at this point, I might want to test the date that's being passed in, because we don't want to set it before the Gregorian calendar allows us to set it. Otherwise, we're just going to have a bogus date. I'll just leave it like that, because we can go far into the future. I can recompile it, rerun it with no change. But then if I go into the code and I'm trying to set it to an invalid year, so it didn't allow me to set the date to 1581 because I had that check in there. So other checks that you could put in here would be to set the date. And in fact, now our date parameter constructor, instead of setting the year directly, we should set it by calling set year, passing it YY. And then that way, we automatically get this check to make sure the year is greater than 1582. So you can see how we're starting to get more of an object-centric mindset in object-oriented programming, and you could create a class that has all of this intelligence that can hide data, the implementation data and the state data from the user of the object, and allow us to do all kinds of validation checks and so on and so forth, so that our programs are cleaner in main and easier to understand what they're doing, and we can bundle up a whole bunch of advanced functionality within a class that we get to take with us when we make an object.